Hey there, ladies and gentlemen. Here's topic 1.2 of the Unit D, Mechanical Systems. This is like the fourth time I've recorded it today. I'm actually pretty happy because I just did the first one and it actually worked. So let's go through complex machines and hopefully I didn't drinks it. All right, there's a choo-choo train. So as time passed, humans needed to make more complicated machines. We just finished talking about the very simple machines like the lever, the plane, the pulley, all those types of things. Now we're talking about some more complicated machines. And because we were starting to make these more complicated machines like the choo choo there, we needed to power our machines in different ways. Okay. Within the last 2 centuries, the big giant revolution came through, and engineers and other inventors developed machines and devices at an amazing rate. And these things used energies such as coal, oil, and electricity to run. This new technology and energy, the new technology and energy sources helped begin the Industrial Revolution. And you may have learned about that in social, or you will in the future, but the Industrial Revolution, things changed, industries changed in a very quick way, okay, to today. And large factories were starting to exist where before there was no large factories. But in order to get from place to place to get to these large factories, we needed to have machines that went very quickly and very far distances. That's where the steam engine came in. And the steam engine was used to transport goods and all these types of things, larger items all over the country. And obviously, when something like this happened, the standards of living improved. Eventually, the steam engines led to trains like we know today. We live in Airdrie. We have a train that goes right through the city. And these trains travel faster than the horses ever could, and they hauled much larger loads. I like this little picture here of the penny farthing. Bicycles, we're going to be talking a lot about bikes. Bicycles are one of the most efficient machines ever to be invented that translate human energy into motion. Okay? And the penny farthing on the right here is an example of a bike. It's an early bicycle that was designed, and it used simple machines like levers for steering and wheel and axle for moving. If you actually take a look down here, that the pedals are actually attached to the big tire. So the front tire and the back tire, they weren't attached by anything. You notice there's no chains like the bikes we have today. We're going to be talking about those chains momentarily. The pedals were actually right on the big wheel. So complex machines notes, if we were in the classroom, I'd be having you guys copy these down. Let's see if I can move me over there. Complex machines is a system in which simple machines all work together. I like to look at this and think of this like we did with the body systems unit. Remember when we talked about the body systems, we had the digestive, respiratory, all those. Those body systems are made up of different organs. Those organs, the heart, the liver, et cetera, they all work together to make the body system. This is very similar with complex machines and simple machines. Most of the devices we use today are made up of several simple machines, or organs, if you will, and therefore we call them complex machines or body systems, if you will. So the bicycle is a complex machine that contains wheels, gears, levers, etc., etc. It's important to know that a system is a group of parts that work together to perform a specific function. So the bicycle is a system for moving a person. That's the main use for a bike, is to move a person from A to B. Yes, we have fun, exercise, etc., but the main function of the bicycle is to move that person from point A to point B. Within the bicycle are a group of parts that perform specific functions, like I said, such as braking and steering, and these groups of parts are called subsystems. The subsystems in complex machines are typically they typically have one function, and they're usually just a simple machine. So kind of like your organs, your heart, right? So they're the subsystems. All the subsystems work together to complete the task that the complex machine was designed to do. So again, going back to the body systems, all of the organs of our respiratory system complete the task of getting oxygen into our body, getting carbon dioxide out of it. Okay. Linkages. So we were talking about the penny farthing and the bike there. The penny farthing had the pedals on the main tire, on the big tire, and it wasn't connected to the back tire at all. Our bikes that we have today, they are not like that. As a matter of fact, the pedals are not even physically attached to The wheels, the tires, they are joined via linkages. Okay, so some of the subsystems in complex machines that produce motion play a role in the transfer of energy or force. So complex machines move an object by transferring energy from an energy source to the object. What's the energy source in a bicycle? Okay. In a bicycle, we're that energy source. Our pedals, our legs are turning that pedal. So when we're turning the pedal, we need to transport that force or send that force that we're putting into the pedals to the wheels. And the way we do that is through linkages. Okay, and linkages are belts or chains, I should say, that are used to take the energy from the power source, in the case of the bike, us, to the source or to the object that needs it, the tires. Okay? The linkage in a bicycle is the part that transfers your energy from the pedals to the back wheel, and that is the chain, as you can see here. So here's a beautiful picture of a bike, and you can see all the different machines and all the different subsystems on it. So we got a lever up here for brakes. The pedals are actually a lever as well. We got wheels and axles on the wheels. There's the pedal spin, so there's wheels and axles there as well. The chain transfers the force from the pedal to the back tire. And then we're going to talk about gears soon, but the gears reduce the force that you actually need to apply. So you guys all know if you're riding a bike, you can change the gears so you have to pedal a little harder, a little lighter, those types of things. More on linkages. Many machines use high tension belts instead of chains to rotate objects. So an example is the fan belt in a car. The fan belt's used to spin the fan to help keep the engine from overheating. Okay, and here, if you take a look, it is a pretty complex series of wheels and belts and whatnot that go through that allow the belt to spin that fan. Okay, chains or belts form a direct link between two separate wheels. Okay, so that when one wheel turns, the other one turns in the same direction. So these belts, they're creating a direct link between the different wheels. If one wheel is larger, and that often happens, it will rotate slower, but with a larger force than the smaller wheel. So if you have a large wheel a large wheel and a small wheel, the large wheel, because with one rotation, it'll obviously go slower, whereas the small one would end by moving a lot faster, but you end up by getting greater strength. My robotics students, you guys have seen this when we were making the robots go faster or slower, making them go up hills, those types of things. Chains have less of the reason we use chains versus belts. Our chains have less of a chance of slipping off because the teeth they're held together in the gear teeth, whereas the belts they could slide off like you see in that picture on the side. However, they are more flexible, so you can get them into tighter situations. Transmissions. We're not going to talk lots about transmissions, but since most machines that move objects must transport a larger load, so think of like a truck or something, or think how much a semi truck has to carry compared to a bike. They can't use simple linkages as similar to bikes. Okay, like a bike chain. So a transmission is a special type of linkage for transferring the energy from the engine to the wheels in large vehicles such as cars and trucks. And you guys have heard about this, transmissions in your cars. The transmission contains a number of different gears, as you can see in that picture down below, and this allows the operator to apply a large force to move the object slowly or a smaller force to move the object quickly. All right, this is kind of an important section here, and I've got a prop that we can play with. All right, so gears are essential components in most mechanical systems, and they consist of a pair of wheels that have teeth. Okay, so this is different than the chains. The gears actually interlock together. And when they rotate together, one gear wheel transfers the turning motion and force to the other. So take a look at the picture up here. We've got a small gear and we've got a large gear. If this small gear was to turn one full rotation, this large gear would barely move. But on the same token, if we were to take this large gear and move it one big rotation, this small gear will end up by turning a whole bunch of times. The larger gear wheel rotates more slowly than the smaller gear wheel, but it rotates with a greater force. So the larger one, it would move slowly, but it has a greater force attached to it than the small one does. And gears can be used to increase or decrease the speed of a machine. Okay, so examples of cars and bikes. And we've seen this when we wanted to go faster and slower on our bikes. Okay, they can also be used to change the direction of the motion of a mechanical device, like a handheld egg beater. I'll talk about that quickly. Here's my handheld egg beater. I'll make my screen a little bit bigger. So I'll move me down here so you can actually see me. So here's a handheld egg beater. What it means about changing the direction is I'm taking this and I'm spinning it upwards. Okay, so it is a vertical motion. It's still spinning, it's still rotational, but it's vertical, moving up and down, and it's causing my egg beaters to spin this way, so horizontally. So it changes it from a vertical to a horizontal. We'll talk about how we can change the speed in a second. So how gears affect speed. I think I can keep me up there. Okay, gears like those, like these, like in this picture right here, increase the speed of rotation of a device. They're called multiplying gears. So gears that increase the speed of a device are called multiplying gears, and reducing gears decrease the turning speed of a device. In reducing gears, the driving gear is a smaller and has fewer teeth than the driven gear. Yeah, I think this is the last slide. Yes, it is. So let's go back. Oops, sorry. Let's go back here to this. And we're going to play with the egg beater again. Okay, so let's make it bigger again. So we can see this right here with our egg beater. So with the egg beater, I have my really large gear. Okay, and if I turn my really large gear one full rotation, okay, you take a look right in here, you can see two smaller gears. So one rotation with the large gear causes the smaller gears to rotate probably about 6 or 7 times. I'm not positive here, but it's about 6 or 7 times. So that means one rotation with the large gear causes the smaller gear to move 6 or 7 times as fast. Okay, so it is definitely multiplying the speed. If I was to, and there's no real reason to do it with this, but if I was to go and take this and make this my main gear, okay, my main gear, if I spin this one around one full time, you can see that my large wheel right here does not spin as fast. It spins slowly. But my small ones down here are spinning really quickly. Okay. So when you do this, it's going slow, but there's a lot more power going on the upper one. Okay. So again, my robotics students, when we took robotics class, we were able to make my robots go really, really quick. And if you've seen these Lego robots, they're not the fastest. They don't look like the fastest things in the world, but you could get them going down that hallway where it would be really hard for us to keep up with them. But there was a downfall. Whenever you would sacrifice speed for strength, the robots started zooming all over the place. So they'd go really fast for a bit, and then boom, they bounce right into a wall, okay? Because they weren't very stable. On the flip side, we could switch it so those robots went really, really slow. And it's so unfortunate that you robotics kids aren't going to be doing the sumo challenge. But some of you already realize if you set up gears and you make the gears so the robot goes really slow, actually get a lot of power. So it's going really slow, but it's pushing those other robots out of the sumo mat. So that's it. That's it for mechanical system. We went through complex machines. We went through this very quickly. There is more information that I normally would go over, but because of the whole homeschooling thing and whatnot, we're keeping it short and sweet. If you have any questions, by all means, give me an email. Some of the stuff will be on the quiz. Make sure you have this with you. Okay, do the quiz on D2L and have YouTube on your phone or something, and go through it. And you should be able to ace it. All right, have a good night. All right, sorry, good day.